Good evening. Welcome back to AP Stats Notes Online. We're going to keep talking about confidence intervals, and hopefully we've gotten comfortable with level and interval. Make sure that you understand there is a difference in how to interpret those two. It sounds kind of splitting hairish, but they do mean two different things. They talk to us about two different things. So you got to make sure you're pretty straight with that. What we want to do now is start trying to figure out where these intervals are coming from. How do you calculate these intervals? And so first and foremost, what is the formula for calculating a confidence interval? Well, it's pretty straightforward. We know that we're going to start with some point estimate and then add and subtract from that what we call the margin of error. The point estimate is always going to be whatever we get from our sample, whether it's a proportion or a mean, or you can, again, just so that we're very clear, we can create a confidence interval to estimate any population parameter that we want. It doesn't have to be means or proportions. It could be ranges. It could be IQRs. It could be standard deviations. It could be Q1s or Q3s. The reason why we focus so much on means and proportions in here is that we, one, the pretty basic measures, and two, it's pretty quick and easy to get our sampling distribution being approximately normal. So, but just understand that we can do this for anything. So to get the estimate, we just grab our sample and do our statistic calculation, whatever it is that we're measuring, whether it be a sample mean or a sample proportion or sample whatever. And then we have to add and subtract out this margin of error. Okay, now, estimate, no secret where that's going to come from. This margin of error, where is it going to come from? Well, the margin of error basically breaks down like this. So your estimate, again, is going to be your statistic. And then your margin of error comes from actually two different places. Number one, we'll use some critical value, and we'll talk about how to get that critical value going forward in the next two next two sections. So some critical value, and then we multiply that critical value by the standard deviation of the statistic. Now, standard deviation of the statistic, okay, suggests, first of all, that it's different than the standard deviation of the population. In notation world, right, standard deviation of the statistic is going to be sigma sub x bar or sigma sub p hat, but in other words, it's from the sampling distribution. Okay, and it's I think important to understand that because there are conditions attached to when we get to use these confidence intervals to help us estimate parameters. So that's where everything comes from. Now, if you can think through these two pieces, the critical value and the standard deviation of the statistic, first of all, you should understand that the critical value is going to be, it's going to be driven by, so I'll write it down, it's driven by your confidence level. For different confidence levels, your critical values are going to change, okay? And as your confidence level changes, how that critical value changes is going to be very sort of logical and commonsensical by nature. So let's take a look, right? So one of the things we did in our estimating M activity was, how do we make our intervals smaller? We talked about, larger intervals, smaller intervals, the drawbacks and the advantages to doing either one. Obviously, a smaller interval suggests less confidence, right? If we create a smaller interval, then we're less confident that we're actually going to get the population parameter in there, right? So that should make a lot of sense. We talked about larger intervals, right? Larger intervals means more confidence, right? But lots of plausible values. We only keep saying plausible and not possible. Any number is a possible value for a parameter, but plausible values suggest a little bit more accuracy, okay? So there's definitely a trade-off here. And so we got to be a little bit careful about larger versus smaller intervals. Now, how? Obviously, we want a smaller interval so that we can have fewer plausible values. So how can we reduce the margin of error? Remember, the size of your interval is going to come from your margin of error. It's whatever we're adding and subtracting to and from the statistic. So how can we reduce the margin of error in a confidence interval? In other words, how do we make this smaller? Right? Well, we're multiplying two numbers together. How do I make this product smaller? Well, you can either make this guy smaller or you can make this guy smaller. In order to make this guy smaller, you have to drop your confidence level. Okay? If you reduce your confidence level, since your critical value is driven by that, then a smaller confidence level means smaller critical value. Now, are there any drawbacks to these actions? Well, obviously, if you drop your confidence level, then unfortunately you must be willing to accept lower confidence. Now, we're not as sure that our interval is going to capture the population parameter. So we have to understand that. Now, making this guy smaller isn't the only way to do this. To make your margin of error smaller, we can leave this guy the same size, but then drop the size of this guy. Now, how can we drop the standard deviation? How can we make this guy smaller? Think about it in terms of the standard deviation calculations, right? For means, it was always sigma over the square root of n. And for this guy, for proportions, it was the square root of p times 1 minus p divided by n. How do I make either one of these two smaller? Well, if I make the denominators larger, right, a larger denominator means a smaller number because it's a fraction, right? So what we could do is increase our sample size, right? Increase the sample size. And now our standard deviation of the statistic will be smaller, and therefore our margin of error will be smaller. So there are ways to reduce your margin of error. It just depends on if you want to carry out those ways or not. So reducing the confidence level we probably aren't going to want to do very often because it does mean that we have to accept lower confidence. Increase the sample size. So we're going to do that all the time, right? Increase the sample size. Why would you not want excuse me, why would you not want to increase the sample size? What are the drawbacks for increasing sample size? Okay? Well, how about we write these out if you're thinking about them, right? Drawbacks. Number one, and we've talked about this before, if you increase your sample size, it could cost more, and could be harder to carry out. Okay? Now, the second drawback that you have to be a little bit careful about comes from a set of conditions that we're going to make sure are true in order to make sure that our confidence interval is as accurate as we want it to be. Okay? And those conditions, again, come from these different pieces of the interval itself, right? Statistic. What guarantees, not guarantees, what makes a statistic an unbiased estimator, or at least reduces the amount of bias, and that is if we're random sampling, right? So if we need to randomly sample or randomly assign to treatment, And this will help our statistic become an unbiased estimator, okay? Or at least reduces bias. We all probably ought to say that. Random means that we reduce bias in our statistic. Maybe that makes it an unbiased estimator, maybe it doesn't, but at least reduces the bias. And again, what makes that statistic accurate? Well, obviously, if we're asking questions that are poorly worded, or if we're grabbing the wrong type of sample, a convenience sample or a voluntary response sample, then we're not going to have much confidence in the statistic that we get. So we want to make sure that we're randomly sampling or randomly assigning the treatments. What's next? Well, the next thing is that critical value, and what you're going to see in the next two sections is that it does come from the fact that our sampling distribution is a normal distribution. We keep referring to two standard deviations out from the mean or from the statistic as being 95% of the values being within those two standard deviations, and that comes directly from a normal curve. So we would want to make sure that our sampling distribution is normal. Now, depending on what we're estimating, that those conditions are different, right? It needs to be approximately normal. Okay? And we'll talk about those specific conditions when we get to proportions and means, okay? And then the last thing is within this standard deviation of the statistic, you have to think back to what condition comes along with the standard deviation. And that's your 10% condition. Okay? And that is, we're not sampling. We want to make sure that we sample less than 10% of the population. Okay? Now, there's the second drawback to increasing your sample size. You run the risk of sampling too much. Okay? If we increase our sample size to the point where where n is now greater than 10% of the population, and I can't seem to write a 10 there for some reason. Then our calculations become a little less accurate. So those are sort of our conditions. And that's 10% condition is also known as the independent condition, right? It goes all the way back to that binomial or those random variable probabilities where every time we sample without replacement, the probability of the next thing being drawn is a little bit different than the first one. And so as long as we're sampling less than 10% of the population, the probability difference in our sampling is negligible. Okay? So it's also going to be called the independent condition. So we'll probably switch over and call it the independent condition as we move forward. Okay? So that's the second drawback to increasing the sample size. So what are we talking about with these confidence intervals, right? There's an applet from your book, from the online book, that you guys know that you can actually get to the online book, at least the applets, without having to log in to the site. So in your book, there is an activity in the chapter that gives you the website to go to get to the applet, right? And so let's kind of play around with this thing for a minute and see what's going on, right? Let's talk about 90% confidence levels. This gives you an idea of the different confidence levels you could end up constructing, whether it's 80%, 90%, 95%, or 99%. So we'll start with 90%, okay? So here's what we're going to do. I'm going to ask you to take, so we're going to try to estimate mu, some population mean, okay? So I'm going to ask you to take a sample, okay? And what it's doing is it's taking a sample of size. Let's see, do we have the size? No, we don't. That's okay. But we took a sample and constructed a 90% confidence interval, right? So when we construct the interval, we are 90% confident that this interval from this value to this value captures the population parameter. And as we see here, this interval does, right? This vertical line represents where the mean is. So there's our statistic, and this is our margin of error going either way, right? And so we've got a hit. All right? Let's go 10 times. Okay, there we go. Now, the difference between level and interval, and we'll make sure we do this to hammer this home a little bit, okay, is that level says that 90% of all possible samples of the same size from the same population should or will produce an interval that captures the population parameter. Now we've got 10 samples. So it's sample, statistic, margin of error, captured. Sample, got a calculator statistic, margin of error, captured. And each dot represents a statistic, and then the lines represent the margin of error. And as you see, out of those 10 samples, all of them captured the population parameter. Now, if we did many samples, okay, so let's reset this, and now let's have it take 50 samples, okay? There's 50 samples. 90% should capture the population parameter. And if you go down through here, there's 2 red intervals that did not capture it. Right? Then this doesn't mean anything went wrong. There's nothing wrong in our sampling method, and there's nothing wrong in our calculations. It's just that 10% of these samples actually won't, just because of sampling variability. That's it. Margin of error, remember, just accounts for sampling variability. Each sample is going to produce a different value. Okay? Let's keep going. So right now we've got 96% of our samples captured, right? If we keep going, look what happens to percent hit, right? It keeps dropping, keeps dropping, keeps dropping. And if we do this enough times, we've got 650 samples so far. If we do this enough times, that percent hit will gradually get down to 90. If we had all possible samples, it definitely would. And this applet may not go that far. It'll stop letting me take samples at some point, right? We're at 91 now. And as I clicked, you kept seeing some red intervals here and there. So that's what confidence level means. If we keep clicking sample 50, it gives us a new set of 50, and so 90% of all possible samples of a certain size from a certain population will create an interval that will capture, okay? Now, let's try this, right? Let's take a sample of 50 here. Right now, our confidence level is at 90%. What's going to happen to these intervals? Look at how big these intervals are. What's going to happen to those intervals if we want to increase our confidence level to 95%? Now, I want more of my possible samples to create intervals that will capture the population parameter. Right? Now, I want this guy to capture the population parameter. How would that happen? Well, if the interval got bigger, right? So if I click this, the intervals get longer. And now, those 2 that didn't capture the population parameter, now they are. Okay? So confidence level, as we increase confidence level, we lengthen our interval. As we decrease confidence level, we shorten our interval to the point where more of our intervals will not capture the population parameter. Okay? And you can see that both in the number of red lines that you see and also in the percent hit. If I go back to 95, 100% hit. If I go to 90, 96% hit. If I go to 80, 92% hit. And again, these are just 50 samples, which is why these numbers aren't exactly matching up. Obviously, if I go to 99%, look at how long those intervals are, right? You want to be 99% confident in your intervals. You can do that, but it makes the intervals so large that it gives us a lot of plausible values to consider. And so I think less of an idea of what the population parameter might be, okay? So some things that I wanted to show you here in terms of how to make our intervals bigger and smaller, and hopefully we understand now the difference between level and interval, right? And I want to make sure that I've said that. So one sample here, we can interpret this guy, and that would be our confidence interval interpretation. We are 99% confident that this interval captures the population parameter, which it did, okay? It's when we start sampling a bunch where we start interpreting level. Now on 99% of all possible samples of the same sample size from the same population will result in an interval that captures the population parameter, okay? And you can see that here in the 99% hit. Okay? Hopefully that stuff makes a little bit more sense. And again, it's, we have our conditions. We want to make sure that we understand that margin of error only covers our sampling variability and not poor sampling or poor assignment, random assignment, or not random assignment, but poor assignments to treatments, because we can do this out of experiments as well. The other thing I want to make sure of is that make sure you understand is that when we calculate our interval, it's based on an SRS. Okay? Now, there are obviously other good random sampling methods in terms of stratified and cluster sampling. But when we start doing cluster and stratified sampling, our calculations get a little bit more complicated. And so we want to make sure that the data that we're getting in order to create our intervals are coming strictly from an SRS. Okay? We'll see that in the conditions that we check going forward when we start estimating population proportions and means. Okay? All right, guys, have a good night. We'll see you tomorrow. Homework is in the text.